Let's continue with our exploration of continuous probability with the focus on the normal distribution. This distribution will become the basis for most of the rest of this course. As we stated already, the probability in any interval in a continuous distribution is equal to the area under the graph in that interval. The normal distribution is widely used in statistical inference, that is, using information from a sample to predict probabilities or properties of a population. The normal probability distribution, also termed the probability density function, can be represented mathematically with this formula. Other than the constants pi and e, you only need two values to define the normal distribution: the mean and the standard deviation. You will recognize the shape of this distribution. It is symmetric and bell-shaped, not skewed. And to restate, in order to describe a normal probability distribution, we only need the mean and the standard deviation. The highest point on the normal curve is the mean. And because it's symmetric, that also happens to be the median and the mode. The mean of a normal distribution can be any numerical value, negative, positive, or zero. And the standard deviation of a normal distribution determines the width of the curve. Larger values of standard deviation result in wider, more spread out distribution curves. Knowing that the normal distribution is symmetric and the mean is in the center, we know that the area to the left of the mean is half the total area. Therefore, the probability of being less than the mean is 50%. If you remember the empirical rule for a normal distribution, we know that 68% of the values are within plus or minus 1 standard deviation, 95% within plus or minus 2, and 99% within plus or minus 3. Those values also represent the area under the curve in those intervals. And consequently, since we know that the area under the curve in any interval is the probability, we can see that the probability in this distribution of being between minus 1 standard deviation and plus 1 standard deviation of the mean is 68%. The same with plus or minus 2 and 3 standard deviations would give us the probability of being in that interval.